very much. Yeah, here we go. Okay, good afternoon. So what's been happening is that this thing goes off after 2 minutes. So I've got 2 minutes to tell you everything. But let's see how it goes. So I'm from South Africa. It's my first time at DDD Europe, and so thanks to Matthias and everyone else for inviting me. And the most common question I've heard from speaking with people at the conference is, isn't South Africa far? And the answer is yes. Okay. For me to get from my home in Cape Town to where most of my clients are in Johannesburg is 2,000 kilometers. And that's within my country. So to go from the bottom of South Africa to get all the way here, flew to London, and there we go, 2 minutes. Flew to London, and there's fog in London, and the flights were off, were cancelled for about 6 hours. And then I looked, and I said, London to Amsterdam is about 350 kilometers. That's a drive, right? It's really, really close. The other thing is that I don't get fog where I live. The sun gets up a lot sooner than here. And it's a whole lot warmer. So, I'll say this, life in the colonies is actually not too bad. We have corruption. We have issues with our version of democracy. We have, what else? Inconsistent electricity supply. So we have rolling blackouts, and we've invented a word for it called load shedding. Basically, we take load off the grid, and then life carries on. So it's interesting out there. Putting together this talk has been really difficult for me. It's probably the toughest talk I've had to put together. And I was stuck with, how much of code do I show? I don't like showing code because we get stuck in the little details and it's hard to follow. And it's not about the code. It's about how we think. So it's been a really, really tough talk to put together. But I am here. I'm not an expert in functional programming. I'm not an expert in logic programming. I am an experimenter, and I try lots of little things, and I try to share what I learn. What I'm sharing with you today, my explicit purpose is to get some feedback. And if some of you find a little nugget in there, maybe you'll also try some things, and then maybe some other things will happen. So I'm really keen for us to push the boundaries of what we're doing. And sometimes one or two of those things might just work out, and someone might be able to do something better than they did before. So that's what we're after. So this bit, what do we do? The reason why I put this question up is because my mum is 87 years old. She turned 87 last October. Born in South Africa, grew up in South Africa, in probably the most boring family ever, right? My mother was a doctor. My father was a medical doctor. My brother's a doctor who married a doctor. My other brother's a pharmacist who married a pharmacist. And amongst all my aunts and uncles, we probably could hold a medical conference. When I was about 16, 17, my father very politely came to me and said, you know, Aslam, being a doctor is a good career option. You should think about it, right? And I never called my father dad. I called him Abba Jan. Abba means father, Jan means love. And I like that word. You tell your father you love him every day. So I said, Abba Jan, I'm not doing what you do. You work too hard. When people are sick, you have to wake up in the middle of the night and see to them. So I'm going to do something else. And I studied electronic engineering. And so my mom thought I fixed TVs. And then I got my first job, and it had nothing to do with software, with electronic engineering. It was writing code. Now I wrote code, but from an engineering point of view, like embedded controllers and stuff like that. But my first job, the first task was, there's a table and it has keys. And we have to, like, what's a table? And what's a key? And it's like, oh, it's data that's put somewhere, blah, blah, blah. Then my words to my dear Abbajan came back and bit me, because for the next few years, I worked harder than he ever worked in his life. And I sat up to ridiculous hours post-deployment, trying to make not people work and get better, but bloody computer, to ridiculous hours of the night. So, how many of you are suffering the same problem I suffer? Not being able to tell your mom what you do in a cohesive way, and so your mom tells people he's into computers. Right? So, the question I have for you is, what do we do? And I bet you don't know. Right? Because I can tell you that there was a moment a few years back, and I got home every day, pretty exhausted, intense project, and my son was about 10 years old. And he asked me, so what am I doing? And I said, no, I'm busy with this parser, right? And he was like, what's that? And then I said, well, it does. And then so the next few dinners, it was like, so Dad, how's your parser? You know, like, you really don't know. You're just trying to be nice to me, right? So, but again, what do we do? So I've, not coming from a computer science background, learning this stuff accidentally, trying my darndest to explain to everyone in my family what I do, who actually only talk about drugs and medical stuff. And this seems to be more interesting. So I've tried to simplify it. What do we do? So we have a problem. And then we have conversations with people who have that problem. And sometimes the people who have the problem are ourselves, right? So we're trying to solve this problem. And then we do this crazy thing called design, and it might be on a whiteboard, and we sketch things, and we try things out, and we might write some code. But at the end of the day, those conversations translate into some code that's compiled, or somewhere that's found to be executable, and it runs. And that's an amazing feeling, regardless of whether you waited till ridiculous hours at night when you just started your career, and even till now some people do. Now, I'm really, really hoping that the people we've had the conversations with are the people that are using the software that's running. Because if you're not doing that, you need to find the people who are actually using your software and have conversations with them, otherwise you're speaking to the wrong people, right? And it feels like a very linear process, but it's incredibly fluid. And we also do this bit, right? We fix mistakes. And mistakes happen. We're human. But we also do this. And we've learned that we should be doing this. This wasn't obvious to us. That we see some things happening that we didn't anticipate or expect. We observe that, and then we go and we change it. And we change what we originally thought, and hopefully for the better. And as we've gotten better at building software and doing what we do, we sometimes do this. All the way from people who are using the software, we learn something that we never anticipated in those first conversations. Now, if we can do this more often, we get even better. There are also occasions when that happens. Like in the act of someone using the software that we've built, it reveals an entirely different problem that we never thought existed. And so that's a powerful moment. So you go all the way back and you start working with that. Or you could say, well, yeah, that's a nice problem, but let's leave it to one side. So that's my naive, simple way of explaining things, and it's taken about 4 transitions and 2 slides, and my mom won't get this, right? So I do stuff with computers on that side. But there's another perspective here when I think about this, and that is that in that early stage, where we're grappling with things and we're having conversations, we're actually trying to understand something. We genuinely are. And later on, we're trying to apply that understanding. But it happens so fluidly. We analyze, we design, we write some code, we push it into production, and it becomes this thing where nowadays we actually want to get it into the hands of our customers or users as fast as possible because we really, really desire that kind of feedback. But there are genuinely 2 parts where we're actually trying to understand and then we're applying what we're understanding. It just happens so fluidly. And that feedback part is where we're updating our understanding, is that we thought we knew, but hey, there's something else that's come up. So we update our understanding. And from a long time of working with different things, and we talk a lot about complexity in domain-driven design and how we deal with complexity, and accidental complexity, and essential complexity. But that early part is generally dominated by the complexity of that domain. How small or how complex or how simple or how complex is completely dominated by that. We haven't laid code yet. May have, but it's acceptable. And so here, we start off with a high degree of ignorance. And so we've invented tools that help us understand more. That's not about coding. That's about understanding. And so we need tools to help us understand. On the other side, that's actually dominated by the complexity of change. As Kent was saying, is that coupling and change, we deal with change, right? Now, I used to say that to many of people I work with, that when you write code, the code that you wrote before it was running in production and the code that you touch after it's in production feels different. There's times where you can just mess around with that code before it hits production, and afterwards you suddenly have this burden of responsibility and care that suddenly overtakes you and sits on your shoulders that like, oh geez, I better be careful about that. And so that's about dealing with change. And so on this side, our understanding is actually a lot higher than on the first side. And so here we're dealing with, we actually need tools to help us deal with change. And I think we're getting better at it. I don't think we're stuck. I think we're actually genuinely doing well. So then the question is, given those 2 kinds of complexities, what tools do we have? The obvious one here in the middle is that things we've been using for a while. Things like patterns, whether it's Gang of 4 stuff, whether it's domain-driven design things, all kinds of things. There's refactoring thrown in, there's test-driven development, there's other kinds of testing. There's things we've heard about over the last couple of days and for months and years before, like microservices, which are architectural styles, coupling and cohesion, all of those things, those are the tools that help us deal with that part. And then on that side, it's become this thing around continuous delivery. And there's a relationship between the first and the second. Has anyone read the Accelerate book? Jez Humboldt, Nicole, and Jean? If you haven't, you should. It's actually an easy read, and it's a defendable thesis based on research, which shows causality between the things that we deal with in building software. And one of the things is continuous delivery, combined with how we create flow, which is how work moves, combined with continuous delivery, has a genuine impact on organizational performance, together with culture and a few other things. But it's one of the causal lines. But what enables continuous delivery is your architecture, which is that design part, and your microservices. So continuous delivery is pushing the boundaries on that side. And it's really, really interesting what we've been able to do with that. And of course, we've spoken about this a lot over the last couple of days and for the last 15 years, and maybe more. Ubiquitous language. And that spans everything. And it probably goes all the way to run, right, when we're speaking with the actual users as well. It's a closed loop, right? So, but let's leave it there. So what do you notice about those tools? We've gotten really good in the middle. That's my feeling. It's just my opinion. And we're getting better on the ends, but it's pretty thin. And so, what about those parts? I ask myself the question, how come my toolbox on those ends aren't as rich as the toolbox I have in the middle? And that is what I'm dealing with. And that is why I experiment, because I want to try to fill up those toolboxes. And so when we talk about experiment, it is an operational procedure carried out under particular conditions in order to discover an unknown effect or law. I'm not interested in laws, creating and inventing laws. My controlled conditions tend to be fairly relaxed at times, depending how I'm feeling and how much pain I'm facing. But it is deliberate. I'm trying something to try to learn something. And so about 2 years ago, I gave a talk at another conference where I took the same thing and I said, flanking code, we can do amazing things with data. And you can find that link and follow and have a watch at that. Or ask me for slides and I'll share it with you. But that's one way. And I spent a fair bit of time, about 2-3 years, maybe longer, looking at how we can leverage data as part of the tool set. And it's valuable. Now I'm asking myself about this part, right here, this early part. And I said experiments in reasoning. It's an odd word, reasoning. It's the use of reason. And this is where you've got to love English language, right? Reasoning, what's the definition? The use of reason. Thank you. Now I need to do one more lookup. I hope it's in cache. All right? Especially the drawing of inferences or conclusions through the use of reason. Thank you. So what is reason? It's the power. That's a big word, right? Power. It's the power of comprehending, inferring, or thinking, especially in orderly, rational ways. And there's that word in there. Rational ways. I would never have associated irrationality with reason. But clearly, according to this, you can reason with irrationality and unordered ways. So based on just putting this deck together, I've got to stop my nonsense about telling people that's not rational. Yes, you are reasoning, but it's not my kind of reasoning, that's your kind of reasoning, and yeah, it's fine. Might not move us forward in my world, but if it helps you move forward in some irrational way, it's fine. But anyway, the 2-minute thing. Okay, let's see what it does. All right, we're back. So we're interested in, what I am interested in is, how do we reason about things? How do we actually understand something and make things better? And can we draw some conclusions from that? So what I do know is that by applying object-oriented design on that side, on this side, it actually helped me analyze better. It genuinely did. And so, the obvious question is, there's this other thing called functional programming. And if I applied functional programming on that side, what will happen on this side? If you're paying attention, you'll notice the first slide, the company I have is called fold left. And so everything that I think is important, I put on the left-hand side, right? So yeah, so will that work? I don't know. So let's try. So I told you I put some code together. Don't shoot the code. We can argue about why these two lines are terrible and blah, blah, blah. It's fine. It's for illustration. What we do know is that it's doing two things. Just two. It's adding something, it's adding a book to a cart, and then it's updating a total. Two things. If you're taking a functional approach to that, you've actually split it up into two different things. And so we have a function called add to cart. That single line as a signature or is actually loaded. So the first thing you'll notice is that it takes a cart and then it returns a cart. There's no void. It returns something. What it actually tells you, what we can infer from that is that if I give you the cart, I may well be getting back a new cart with the new book in it. Whatever was there before. But it could be new. And in functional programming, that is genuinely true. The reference to the thing that's passed in will be different to the reference to the thing that you get back. Right? And so that's loaded. That's heavy. I found that heavy. Maybe for you it's fine. The next thing that we had to do is deal with the total. And so give me a cart, I'll calculate the total for you. Right? Please forgive me with the double. But in my country where we have corruption, doubles are very useful. It's really useful. Rounding errors? Come on. Oh, man. Judges never put anyone in jail for rounding errors. But we have this is this thing called referential transparency, right? It's a big phrase, referential transparency. And basically it says that a function will always, absolutely always yield the same output for the same inputs. So if we look at the add to cart function, the fact that I give it a cart and I get back a cart, if I gave it a cart with three particular books, and I say add book 4, no matter how many times I call that function with exactly the same things, I will get a new cart back with the fourth book. No matter what. It's two different references, two different objects. So under every circumstance, it'll be the same thing. And so if I took the first cart with 3 and I gave it to calculate total, I'll get a particular total. And I'll do it over and over again, I'll get the same thing. And I took the cart with 4 books, I'll get the same answer every single time. Therefore, we have to treat cart and book as immutable. And I'm being very specific about my use of words. Treat it as immutable. Don't mess with its state. Honor its state, don't change it. And that's a big deal. So let's park that to one side. We'll come back to referential transparency. Something a little bit more complicated. Last year, I had to do something. There's an object U, and its state changes were fairly complex, and the consequence of changing state is also fairly complex. So we said, why don't we model the state transition separately from the object whose state we're interested in managing? And so we built this finite state machine. And that's fine, right? So not uncommon. Happy to do this in object-oriented land, and it'll be absolutely fine. But we said, let's try something from a functional point of view. This first bit is basically the way we set up the state machine. And there's an object called correspondence, and we create a new state machine to handle that. The first state we're interested in is allocated, so we configure it. And then we say permit a transition called allocate when the correspondence is, well, it should be not allocated. And then when you're done, transition to the next state called allocated. Simple enough. Not too bad. Easy enough to configure. It's not necessarily functional programming. It could be like a fluent style, and it's got object dot whatever, so it's fine. And then we could use this finite state machine. And the one we're genuinely interested in all the time is firing a transition with the correspondence object and getting a new correspondence object back. That part feels more like functional because we're always getting a new correspondence object back. And that's leaning towards referential transparency. However, if we think about the problem, we want to call that function fire with a transition and an object. There's a few things that need to happen. First, I need to execute the onExit function for the state I'm in. Then I need to execute the transition function. Then I need to run the onEntry function for the destination state. So there's three things I need to do. And so you have to ask yourself, what are the inputs? What does it return? How do I handle errors in those three things? So something which seems so wonderfully simple and procedural. And yes, I can throw exceptions. And I'll have to, if I throw it, someone else is going to deal with it, which is fine. Maybe not if you're working with them. But we ended up with this. So sitting behind that fire function was another function which we called makefire. And if you read it very carefully, it says execute on exit, get the current state, and then execute change state with the next state, and then execute on entry. And it feels like what we drew. But here's this thing that's going on here. Firstly, this makefire function is returning a function. So function is a type. The second thing, it's not U, it's option U, and option is an algebraic data type. And then is function composition, and then that apply is actually curried because execute on entry takes two inputs, and we're giving it one. So who understood what I said? It's okay if you admit ignorance, it's fine. And I've been deliberate about that, because this is the issue I have with functional programming world. No one knows what the hell they talk about. They use this language which is so ingrained in mathematics and category theory, and it's true, it is. But the barrier for entry is so incredibly high. And then they'll talk about monads. And at the end of the day, we're just trying to glue functions together that can't fit. So put some spit and polish and other things and stick them together. But then we'll go into say, no, this is an endofunctor of this and blah. It's like, it's crazy. We can't survive like this. And so my appeal to the functional programming fraternity, and I think I'm a junior in that, is that people help us. Make it easier and more accessible, because we actually want to benefit from some of these things. So, even with what I did, that's still the question. So the thing I want to know, and you probably want to know, is that that's an experiment. What did I learn? Well, firstly, and unsurprisingly, it encourages single responsibility. Now, in OO land, we talk about this very, very often. And sometimes, if you go to an OO pub and you don't have single responsibility, you probably get lynched. They won't buy you beer. And you'll be kicked out. So, if you wear an FP hat, there's a better chance of surviving in an OO pub. Because it encourages that, like you saw with the cart. It discourages side effects, right? That is, don't do things that's outside your scope. So I made up these simple rules to help me survive, which is that if it's not in scope, don't touch it. Leave it. Deal with it later, right? And that simple rule is quite mind-numbing. The other thing that happened, which took me by surprise, is that in object-oriented world, we encapsulate things. We hide the data structures. We expose an interface. And we often talk about, don't let your internal structure bleed out. So give me a reference to an iterator. Don't give me the collection itself. I don't need to know that it's a list or a set. But here the data structure is in your face. It's right there. And anyone can go and mess around in it. touch stuff. But then, if things become immutable, it's okay to open the curtain and show the inside of your lounge. You can't just move things around. But you can write functions that changes it and create some new state, which will be a new lounge. But that's the thing, immutability becomes your safety net. And there's another thing that happened. Because of immutability, when I had started having conversations with people, trying to understand their problems, time actually became an important thing. Now, often, what I've seen is that people trying certain things out might suddenly stick on, on a table in a database, changed on, added on, and they just keep track of it as a second-class citizen. Time becomes important, and the way we reason about our domain over time becomes important, because that's the real world. Time is part of the real world. And so I often found myself accidentally putting myself in a snapshot state to think about what's happening in this domain at only one instant in time. And the moment I realized that every time I would do something in that domain at that instant, the next instant has new state. And so time becomes important. The way you work with it, the way you model it, becomes important. It didn't come for free. This referential transparency stuff came with an incredible amount of unlearning. I taught myself, 16, 17 years old, to write some code and carried it through my engineering, and now I still do it. And everywhere I went, it was everything I learned, every new language, it was I equals I plus 1. It's not referentially transparent. It's not. I had to unlearn all of that. And it feels weird. The other thing is, programming with immutability was also unlearning. And it felt weird. So now we're in DDD world. We're not saying value objects are immutable. We're saying everything is immutable, even your entities. Like the shopping cart stuff I was showing you. That's crazy. And so every single time you start making changes in place to something that has state, after a while you start feeling dirty about it. And this is the worst thing. You feel dirty, but you don't know what to do. And then so you just get stuck, and then you try again. And eventually you get there. The other thing I noticed, able to reason about the data structures and the operations on the data structures independently. Now, it's not exactly what Kent was talking about this morning. He was talking about structure of code and behavior. This is about the data and its structure and the behavior and the actions or the operations on that structure. But what I found is that I couldn't, in my head, I am incapable of reasoning about the two things moving at the same time. And so I actually started playing with the data structure and left the function alone, and then deal with what's the consequence on the function. Or I'll play with the function and leave the data structure alone. And that actually became a beneficial thing in the way I actually work and think about things. This declarative stuff has been like a holy grail out there. So what I found is that by leveraging the more intimidating functional programming concepts, like you saw, on exit and then on transition and then on entry, that stuff like currying and higher order functions, etc., it can help you make your code a lot more declarative. It tells you more of the what. The unfortunate part is that behind that, if you're not familiar with FP parlance, it looks hideously complex. And so when I started trying code like this, the next day I had no idea what I wrote. And so we had to figure that out. But good naming wins. Always. Always, always, always wins. So because you're using functional programming, it doesn't mean that you will be declarative. You still got to work at it. It's not a freebie. You got to work at it. There's one more thing that came out of this for me, is that comfortable with tests giving me trust. If my tests pass, I trust the code. And referential transparency surprisingly gave me a sense of trust as well. And tests and referential transparency, all are useful. I'm not saying one replaces the other, but it gives me trust. And when I know something, there is something there, an element that I can trust, I can focus on the things around it. And if I've got two things that I trust, I can focus on the interaction between them. So the book that Kent was talking about, Structured Design, in there it defines a black box in that book. And the first property of a black box is it's black. It's opaque. So you only know about what goes in and what comes out. And that's trust. And so we're after creating elements that we can trust. So this is what I came up with. My functional programming experiments kept me here, right here. And I wanted to go there, on this side. So about 2 years ago, working with a banking client that was giving out loans for vehicles, vehicle finance, they had to calculate a credit score. So I took their code that calculated that in some proprietary language, reverse engineered it, blah, 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 blah. Came up with this graph of what the decision tree and everything else goes into it looks like. And there's over 700 branch statements, like if branch statements, over 500 variables, that are referenced over 5,000 times. That doesn't fit in my head. It genuinely doesn't. In engineering, when we were studying, anything that was more than a 3x3 matrix was a problem for me. Seriously. But at the end of the day, what were we trying to do? We're trying to do A, minimize the risks that the person that we'll give the loan to will not default. They will pay the loan. B, make the most money from them. And then there's another part, some other minor things. Important, but less important. And the other two, which is that what's the value of the asset at any moment in time, what's the value of the loan, and have we broken even, etc. So that sounds like a linear programming problem. There's equations, and we're trying to find the boundaries where it, and there's a sweet spot in between, etc., etc. I did do a course in finite maths. I didn't like it. There were two courses I didn't like. I didn't like control systems. It was crazy. And discrete control systems were just as bad as continuous ones. And in our first semester, we had 2 semesters in control systems 1, control systems 2. And I'm going to be ashamed, but I will say this. As an entire electronic engineering class, our lecturer passed away between the 2 semesters for control systems. And we all had like 52% maximum to pass the first semester. We were very happy, unfortunately. And the new lecturer came and we actually passed the second semester. Bless his soul, Prof. Anderson taught me about linear algebra and all sorts of things. Linear programming was things I didn't pay attention to. I didn't know what it was useful for. And so it falls under this thing of logic programming, right? And here's the thing about logic programming. It's just woof, 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 woof. I have no idea what's going on. But this is what I've learned from life. When you're faced with the problem, the hardest path is probably the best option. So if you do nothing with functional programming, nothing with logic programming, just take stock of your life and look at what's ahead of you, and you're fearing that particular path, you should be walking down that path, because that one will yield the best outcome. over beers, I'll tell you when I've used that. Oh, and there's a flip side to this. If you don't have any options, you actually don't have a problem. Right? If you've got no options, just carry on. You're fine. So, anyway, software conference, you've got to have XKCD. I don't know if you can read that. There's a menu on one side, and on the other side there's a table with someone taking the order. We'd like exactly $15.05 worth of appetizers, please. Exactly, right? Here. These papers on the knapsack problem might help you out. And then the traveling salesperson, blah, blah, blah. But this is the warm-up exercise for logic programming, right? And we're not yet into some of the domains we deal with, but let's play with this, right? So, the first thing we know is that there's 6 items on the menu, right? And so, ignore the language. I'll reveal the language at the end. It's a bit weird, but stick with me. So, there's an array of 6, and with that, there's a price, and I've just multiplied by 10, so I have integers. And these are the prices. We also know that we want the total bill to be 15.05 or 15.05 cents. We also want something that is going to hold the quantities of each item that's on the menu that will be ordered. And it's an array. Now here's a killer. There's a constraint. We're saying that the total bill, which was 15.05, must equal the sum of all the things that we've ordered. So that equals total bill equals is not assignment, it's an assertion, it's a constraint. And then the other thing, because mathematically I could say quantities could be negative and I could still come up with an answer, we'll say quantities must be positive. And here's the thing. Then we say to the computer, go and solve this for me. Solve it. And you know what it actually does? Amazingly, it does. I don't know how it did it, but it did it. Now, what's happened here is that I actually spent my time figuring out what's in the problem domain, and I asked the computer to go figure out the answer. That's different for me. That's very different from me laying out classes and objects and joining them together. Let's go one step further. Same problem, but we'll add another thing, which is minimize the number of dishes that have been ordered. All right? So we had those 2 constraints. We'll add one more constraint. The quantity ordered must be greater than 0, right? And we can calculate the quantity ordered. And then we'll say, solve the same problem, but minimize the quantity ordered. And you get that. 4 items. The previous one was 7. Now that's cool. Even from XKCD, that's cool. That you can write code like that. That language comes from this tool called Minisync. You can go here and play with it. Do you want to see it? It's really boring. I mean, you run code. Should I try? You actually want to look at an IDE and get excited? Okay. Minisync IDE. Here's the code I told you about. Oh, you can't see. There? Oh, where's my cursor? Which side is it? Here? Here? Okay. So stick with me. Same code. Right? So it ran that, and it came up with that. 7 was the first one. Thought you were going to be excited. Here's the next one. And notice that it found 2 solutions, but the last one is the one we're after. So this is the thing. You could have crazy-ass number of variables if you know how to model it, and you know those constraints, and you know the domain or the ranges of things, you can cobble things together and ask something else to solve it. And you know what your biggest challenge is if you don't do this in production? Find the right solver, the thing that's actually doing the solving for you. They actually deal with different matters. Oh, I don't know how I'm going to get this thing back now. So Minisync, actually, I learned a lot from Minisync. I don't use it in production. It's a learning ground for me. And maybe you might want to do that as well. So let's do that. Is that back? Oh, Lord. Right, thank you. Sudoku, another one. All warm-ups, right? So some of us may have written Sudoku. Some of you may have used Sudoku as a hiring exercise for people that want to join you. And there's some wonderful algorithms and some long pieces of code and all sorts of stuff about that. But this is Sudoku. All the numbers are different in each row, in each column, each little grid. Now this code that I'm going to show you is actually C#. We're creating a new solver. I've left out some code, but this is the important part. And you notice there where it says all different. Basically, we're walking a list and saying all the numbers, we're asserting that every number in that list must be different. And then in every column. And I've left out the code that does every row. And ignore what decision builder does, but at the end of it, it says, search for all possible solutions. Done. It comes from that library by Google. It's OR tools. Interesting thing. Google OR tools, that's the URL. Find it, play with it if this is interesting to you. It deals with things like roots. How do you find roots between things? How do you schedule? Right? How do you do planning? How do you do assignment? How do you do packing? How do you do solvings? These are genuinely complex, difficult problems to solve. And sometimes, in my past, when I go back in time, I once was building a system that was doing bulk coal handling for ships that were queuing up along the dockside, and we just used a brute force method. We were lucky that they didn't lose a lot of money, but they didn't know there was some way to make more money, right? But there's science behind this. The mathematics could be crazy, but tools like Minisync, tools like Google OR tools, actually lowers the barrier for entry. That has been my experience. The nice thing about this is that it's got bindings for Java, C#, and Python. So play with it. There may be one or two corner cases or really gnarly parts of your domain that you might want to get some value from. So, experiments in reasoning. Here. Where did we land? Okay, so what did I learn? I played with that feedback loop. It was different for me. I was able to have conversations, lay out parts of it. It's not yet going into production, but it helped me tighten my understanding. It revealed assumptions very quickly. It helped me separate out which variables are significant, which elements should be computed, what are the constraints, what are we actually trying to solve for. Now, remember the credit scoring thing? We didn't need 500 variables. We had just a handful that were significant. The others were intermediary and blah, blah, blah. But with this lens on and this hat on, I was able to start piecing together, playing in the problem domain, in the problem space. And that was different for me. I also noticed that logic languages are a lot more declarative, but they are so strange to what we're used to. Prologue is odd. I tried it, I went away from it. It was just too odd for me, and I found more value in these other things. We can also say that BDD is declarative. BDD is incredibly valuable. It describes in a very succinct way examples, and it guides us. Speaking to Daniel North a while back, and he says he's thinking it should be behavior-guided development, not driven development. So, but I don't know how it feels to say BGD. But the thing about those examples is that it does not reveal the actual constraints and relationships. It doesn't. And it's not the fault of it. It wasn't designed to do that. But there's value in actually surfacing these things, like I showed you with Sudoku and XKCD. And this is the thing for me. The more mental tools we have, the better it is. Otherwise, everything looks like a class and an object. And that's not very powerful over time. Coming from an Indian family in South Africa, there's a thing that goes in the family that says that, you know, as an Indian, you can fix your TV with a hammer. And then I replied to them, I did electronic engineering, and my mother told you I fix TVs, so calm down, right? Here's the other thing. This is a lot more meta, a lot more philosophical. The primitives of the problem space contain the truths. You can peel away the layers until you find the things that are atomic, the primitive parts that you actually need to combine. You face your assumptions very quickly, and you deal with your assumptions very quickly, and you invalidate or validate them very quickly, and you figure those things out, the parts that are important. And you don't rush to create abstractions when it's premature. That's what I found, and it's valuable. This thing of truth is a big deal for me. A friend of mine who has a friend who's a lawyer says that it's easy to be a lawyer because there's an internal consistency to truth. If you ever tried telling a lie, whether you're growing up a white lie with your parents, you'll notice that when you were getting cornered, you invented more things. Like, why did you get home late, Aslam? I was really busy with so-and-so. Oh, but I phoned the house and you weren't. Well, actually, I wasn't there. I was outside. And like, you just go on and on and on. And there's no integrity to the lie. But there's an integrity to truth. And here's the other thing. One of my favorite authors, Paulo Freire, wrote a book, The Pedagogy of the Oppressed. It says that if the structure does not permit dialogue, the structure must be changed. That, for me, works for code. It works for design. It works for life. It hits me because many of us are living with certain structures in the places that we work, in the places that we live, that is begging to be spoken about. We don't have the same equality that we want. In my country, not enough black people have jobs that I have. That's the truth. The structure is off. There's not enough women at this conference. The structure is off. Societally, the structure is off. Therefore, it requires dialogue, because the truth has integrity, and there's literally nothing different between us, apart from my choice of long hair. There's nothing else. And so it's a big deal, this, for me. And it has consistency across my work and my life. And so I often talk about truth, structure, and dialogue. And I'm always finding that between structure and dialogue, somewhere amongst that, the truth emerges. And we're after the truth, right? Really, really are. And coming from a country born in the years of apartheid and going into democracy, you get a sense of struggle. When your identity is eroded, and suddenly you're given an identity, you have a sense of struggle. You have a sense of history. You've got to have a sense of humor. Otherwise, you're messed. So what do? We try to make a difference. That's what we do. And the operative word is try. And if you can't try, just care. So thank you very much, everyone. It's been wonderful talking to you.